So in the last video, Logan spent just a little bit of time talking about data and data being stored in a computer's memory. In this video, he's going to be discussing variables. Now, before Logan gets started, I'd like to remind everybody that at the very beginning of this course, we had said that we were going to present the introductory language fundamentals from a point of view of someone that has already experienced a little bit of basic programming. So we're not going to sit here for the next 3 hours and beat up the concept of variables. We're just going to review what variables are inside of Python and then move on. This will allow us to get to the meat of Python, to really get into working with Python code and creating meaningful applications. So I just wanted to remind everyone of that before Logan got started. And with that, I shall hand you Logan.
As a matter of fact, this lesson is actually broken up such that we're going to cover the practical application of variables before we take a peek under the hood and see what's actually going on. So we're going to approach this first from the, well, I just need to use variables in order to use them. And then we'll take a look at some of the technical aspects, meaning that if you aren't too interested in the actual behind-the-scenes stuff, you really don't have to worry about it. If you're just using primitive types in variables, you really can just sit down and use them.
Okay.
But to get things kicked off, let's begin with what exactly is a variable? Well, in the Python sense of a variable, it is nothing more than a reference to an object. That's it. That's it at the most basic level. Now you might be wondering, well, how does this help me when I need to store numbers and strings and things of that nature? Well, the idea here is that in Python, everything's an object. When you make a number to hold some value, you're actually making an instance of an object. That integer in memory is an actual object.
Okay.
Now, because of some of the rules behind the primitive data types in Python, you don't necessarily have to worry about that. You can sit there and work with numbers and variables all day long and never worry about the fact that they're references. As a matter of fact, we're going to save that discussion to the very end of this video. So moving on, let's take a look at what exactly we need to do to use variables. And that begins with variable definition. And in Python, you define variables simply by assigning them. You don't have to worry about things like in other languages where you have to first declare the variable before using it.
Of a particular type.
Exactly. In Python, you instead simply assign it, and at the moment of assignment, that's when the variable gets created. For example, we can here inside of the interactive interpreter begin with, let's say, the variable named a. Let's assign a value of 1. And after doing that, if we simply type in a at the interactive interpreter, or if we were to print a inside of a program run otherwise, we would see that a resolves to the value 1.
Okay.
So technically, internally, we now have made an integer object and a points to it, but we don't have to worry about that just yet.
Now, in other languages, for those that may have just an introductory overview of another language, they may be thinking, all right, a variable is simply a place in memory that's going to hold this value 1 that you have assigned to it. So what you're saying is just a little bit different here.
Yep, it is just a little bit different. We're actually looking at object instances even for very simple things.
Okay.
And we're actually going to get into the idea of what data can be changed versus cannot be changed. But we'll look at the specifics of that at the very end.
Okay.
But yeah, keep that in mind that we are looking at things a little bit differently. And we're actually going to address the idea of variable typing here in a minute, because you'll notice we haven't declared the type of a, we've simply put something in it. But as far as usage goes, this does mean that variables can be used in a very quick, shorthand, or offhand use. And that is, you can simply, the moment you need one, you simply put values into it, and it magically exists.
Okay.
So we can say A stores the value 1, B stores the value 2, and then A and B reference their associated value. Of course, any type of data you want can be used, so we could say that name is equal to Bob, and now the name variable does indeed hold that value. Now, you had brought up an interesting point, and that is, in other languages, when you're declaring variables, you not only declare them, but you have to specify their type. You'll notice here in Python, we're not doing that. We're simply putting the number 1 in a variable and the word Bob in another variable. That is because Python is a dynamically typed language. Or more specifically, Python, the type of a variable is defined by the value, or excuse me, by the object that it references. Also, by the term dynamic, that means that the variable's type can change. Since an existing variable can be told to reference a completely different object at any given moment, that means that the reference and therefore the type can change. This can be seen by looking at A and looking at the type of the variable A. Type is currently integer. If A was set to cat, A has indeed changed, and the type of A is now a string. Now, to give an example of how this can be useful inside of an actual script, let's switch over to our Python projects folder and create a new text document. Let's name this variables.py. And then we'll open up the script inside of the idle editor. So with this opened up here, let's type out a very simple script using a variable, assigning to it, and then reassigning some data that is of a different type. Let's begin with the variable foo, and let us first set it to be the number 3. Now let's turn around and print out some information about foo. We'll begin a print statement, and we'll say something to the extent of foo equals, I'll close off the quote, and I'll specify a comma so that I can give additional information on this same printed line. So we'll simply add to that the variable foo. Now I also want to show what the type of foo is along each step, so we'll print out another line of information saying something to the extent that foo begins life as, and then specify its type. So foo begins life as, we'll end off the quote, and then we'll give a comma and gather the type of the variable foo. Now if we were to save and run the script, we get the following printed out. Foo is equal to 3. Foo begins life as type integer. So all is well and good. Now let's copy this whole block of code so that we can very quickly duplicate it by pasting. And let's change foo now. Now that it's been shown to the screen, let's change it to be a string holding the word cat. And we'll do the same line where foo is equal to its, or we show that it's equal to its given value. And let's say that foo is now, and then once again give the type of foo. So we'll save and run, and that gives foo is equal to 3. It has began life as an integer. Later, foo is equal to the value cat, and now foo is a string. So once again, here in idle, so an actual a full script being run normally, we can see that yes, we are indeed able to leverage dynamic typing with variables. All right, moving on from here, I want to take a very brief look at the delete statement in use with variables, and that is the idea that you can delete a variable after it's created within the same running Python session. To give an example of that, let's first consider this session here in the Python shell inside of idle. One interesting thing about the way idle works is between running, your session, your Python session is left open. That means unlike a lot of other programs where you begin literally from the beginning with a clean initialized slate, instead here in idle, as long as you leave idle running, you're always going to have all of your variables basically maintaining their life. Things are not reinitialized upon startup.
Meaning that even though your script is now complete, those variables still exist in memory in this shell.
Exactly. As a matter of fact, that differs from running your script from the command prompt back in your operating system, where you do run a new instance of Python to execute your script.
That's right. Hence what you just said about keeping the shell open while it's open.
Exactly. And this is something important to keep in mind just when working in idle in general, and that is once you run your script, your variables are now initialized, so you may forget to do things like initialize them as they simply hold their value. To show this, we could simply at the shell here in idle gather the value of foo, and we can see that that is indeed still equal to cat. Now, if you wanted to return to a state where foo does not exist, similar to our other session we have open, which is back in the interactive interpreter, over in this session, if we try to gather the data in foo, we get an error. Foo is not defined. Of course it's not. We never defined it in this session. However, it is defined in our idle session. And if we wanted to return to a state where foo is undefined, we could delete that variable. To do that, we'll use the delete statement and then specify that foo is the variable we wish to delete. If we delete foo and then try to access it, we see that it is now undefined, just like our other Python session. This can be useful if you're designing your script such that you really need the variable to be gone before your script runs a second time. Now, this is even more applicable when Python is used as an embedded scripting language in other applications. In those scenarios, you may run into a case where your Python session is left open for the duration of that application. So you might run into a scenario where you do want to clean things back off a bit before you rerun a certain set of your script. But again, just something to keep in mind. And also, this becomes more useful when you begin working with more complex data types, and also when you begin working with multiple modules. All right. Moving on from here, let's now advance to the second part of this discussion, and that is variable mechanics. How exactly do variables work under the hood in Python? We began earlier by talking about the fact that a variable is nothing more than a reference to an object. So let's take a look at a simple scenario a little bit more in depth. And to do that, I'm going to use Notepad as a makeshift whiteboard. What I want to do here is I want to cover a little bit of the terminology used with objects and data types, and that is the idea of mutable and immutable objects. Mutable means that the object in case can be changed in place in memory. Immutable, that means that once that object instance is created, it can never be changed. Once it's created, that's the way it will stay forever. The only thing that can be done about it is it can be later discarded. Now, this is important here because all of the primitive types in Python, especially the ones we're looking at, integers, floats, strings, things of that nature, are immutable. They cannot be changed. If you think about it, that seems that that's a bit odd because we're talking about integers, numbers. And we've already seen how we can take something like a variable, set it to 1, then set it to 2, and that seems like, well, aren't we changing that? If we made a equal to 1 and then a equal to 2, it just seems like we would be changing it. But in actuality, in the Python sense, we're actually making a separate instance of the number. Now, to give an idea of what I mean, let me draw that out step by step. Basically, the actions that we want to cover are this. We'd already seen in Python how we could make a equal to 1, b equal to 2. So let's jot this down. First, we're going to be looking at a equals 1, and then later a equals 2. So excuse me, not introducing b yet, we're simply reassigning a. So saying that this had been run where we assign a and then reassign a. In the value sense, you might be thinking, well, you would just overwrite the value in a. But in the Python sense, we're going to be working with objects. So, to draw this out, let's first consider the statement a equals 1. What's actually happening here is we've got this value a, and we're going to assign it an object. In order to assign a, we're going to make a new object, which I'm going to represent with brackets, and that object is going to be an integer representing 1. So here is our integer object, and to assign it, we're basically just making a link between the two. So we're pointing a at 1. And that's simple enough, and so far, as far as any of the practicalities of it, that's just it. A is now 1. Now, in the case of a is equal to 2, what we're actually doing here is, let's copy this scenario. So now I'm saying, again, I'm just shuffling some stuff on the board to make it a little bit clearer. So here is what we're working with. A equals 2, given this as our current data. Well, what's going to happen is the moment we assign that, we're first going to discard the existing integer instance. So I'll represent that here just by blanking it out. And instead we're going to update the a reference and point to a completely new integer object. So basically we make a new integer instance representing 2, we make sure that a references this new instance, and this old one is simply discarded. Now you might be looking at this and think to yourself, well, isn't this going to waste memory? Because we can see we actually have 2 instances at this moment in time. Well, we don't have to worry about that because Python is a garbage collected language. That means it's the garbage collector's job to, at some point in the future, notice the fact that this instance is no longer referenced and simply wipe it out of memory. Now, another implication of immutable objects that I wanted to address was the idea of assigning one variable to another. Because with this in mind, thinking that, well, okay, a variable always references an instance of something, always references an object. What would happen if you made 2 variables and then assigned one variable to the other? You might be thinking that you would run into a scenario where you'd have 2 separate variables instancing the exact same object. And now in a more advanced sense, once we get into our own classes, you actually can do this. You can have two variables reference the same object. But here with the primary types, that is already considered ahead of time, and the interpreter Python itself makes this work in a more value type sense. So there are some rules in place that make it work more, like I said, more in the value sense. And to explain that, I want to go through another scenario here on the text whiteboard. Let's put this scenario together. What if we were to do the following series of assignments? First, we would do A is equal to 1, followed by B is equal to 2, followed by B is equal to A. The first two seem simple enough, as we've seen that in action and have just finished drawing that out. But the interesting thing is what's going to happen down here at this operation. Well, just as we had drawn before, let's draw out the idea of a variable A referencing an instance of an object, an integer 1. So let's see, that is going to be, I'll jot down the actual statement preceding each drawing. So moving on from here, taking this state, keeping it in mind, and then approaching the statement b equals 2, well, what's going to happen here is we're now going to have another integer instance. So now we have 2. We have another variable called b, and b references 2. So far, so good. We just have second variable, second instance. All very easy. Now, what happens in the case of the statement b equals a? Because you might be thinking to yourself, all right, given this as the current state of things, well, it might just be, b is referencing that first value, and this guy gets discarded. Not in the case of primitive types like integer. We do not have a case of b pointing to a. Instead, what happens is this value for b does indeed get discarded. A new instance gets created as a result of the assignment operation, and that new instance is based on the old one. So basically this object is taken into account, a new object is made based off of his data, which means that new object would of course have 1 in it, and then our old reference is simply updated to point over at it. So now b is updated so that instead of pointing at this guy's discarded. A new object is made to represent the old object, and our reference is updated. This is why we could now change a, and b will not be affected. Changing a here, so pointing a at some other value, means that b would still point at 1 and not be affected. We can show that by following it out in the interpreter. If we were to say a equals 1, b equals 2, so we've got our a value, our b value, now saying b equals a, b equals 1, as expected. Now we can change a independently. We can make a equal to 5. And if we look at b, b is unaffected. A is 5, b is 1.
Nice.
Once again, b is pointing at his own object, and it doesn't matter what we point a at now. A is still his own deal. And again, I just wanted to point that out, that it's an interesting scenario because we are working in everything is a reference idea. But in the case of primitive types, they are set up by the interpreter to look like they're working on values, even though behind the scenes they're really swapping values out. But that's why we see how references are working, and also why, in the primitive sense, the references are independent, because new references get created by the assignment, and in the case of working with immutable objects. Now, we're not yet going to cover the concept of an actual mutable or changeable type just yet. That'll be coming up here in some of the more advanced types when we look at lists, and later in time when we begin to look at our own classes. But with that, that is really going to wrap up the variables lesson. Once again, we simply covered some of the practical uses of variables, and we looked at how exactly variables are working in the object reference sense. Okay. So with that, that's going to wrap up this video.
Thanks a lot.